Well, hey everyone. Today we're going to learn our fourth and final method for solving systems of linear equations. The last few class days, probably going back a couple weeks now, we've been talking about solving a system of linear equations, which essentially means you're trying to find the intersection point between the two lines. So we graphed the lines to try to figure out where that intersection was, and we came up with coordinates for that intersection, like if they crossed at 1, 3, then that would be the solution to our system. The two equations, then we put them into tables, and we would have some values on our tables. Let's say we had something like 4, 6, 8, 10, and then on our other one, maybe we had 1, 2, 3, 4, and maybe we had, 5, 6, 7, 8, and we noticed that on the two tables that they share this value of 2, 6. Every place else is different, so the place where these two lines cross is going to be 2, 6, and we can see that on the table, as well as if we had graphed those lines. We then went on to take a look at solving with substitution. So we talked about that method over the last few classes, and our final method is called the elimination method. Now, the elimination method is also going to be an algebraic method. By the way, I'll apologize here if there's a bell that rings while I'm explaining this, but we're just going to power through. The elimination method results in us either adding or subtracting the two equations together. So instead of substituting one into another, we're going to combine them together. So combining means to put together, so write that down. And when we combine like terms, for instance, when we're going through and solving, we're generally adding the equations together, but in fact we can also subtract the two equations. When we are using the elimination method, we can combine by either adding or subtracting. And the whole goal is to then end up eliminating or getting rid of one of the variables. Either the x or the y is going to go away once we add the equations together. So eliminate, remember, is to get rid of a variable, either x or y. Okay, so let's see how that works. We'll notice in example 1 here, there's that bell. Okay, so we notice in example 1 that we have the two equations, and notice neither of the equations is in either y equals or x equals form. So it's going to be tough to make a graph, it's going to be tough to make a table, it's going to be tough to do substitution, because we like one of the equations to be in either x equals or y equals form. But what we can do is add these two equations together to eliminate one of the variables. And so notice what happens when we add these two equations together. So I'll put a line underneath, and when I say add, that means we're adding the x's, we're adding the y's, and then we're adding the constants on the other side of the equal sign. So if we add these together, 1x plus 3x is going to be 4x. 2y plus negative 2y is 0. That's the elimination step right there. And I'm not even going to write the 0 in. I could do like plus 0 here if I wanted to, but the y completely is eliminated, goes away, and so that's really what we're trying to accomplish. And then we have 9 plus 11 over here is 20. Notice how simple that equation becomes when we add those equations together. So when we add the equation together, the y variable is completely eliminated. And now we can solve for the x. Well, that's fairly straightforward, hopefully. We've got 4x equals 20. So to solve for x, 4 times x, to undo the multiplication, we will divide both sides by 4. That cancels out the 4, and we're left with x is equal to 5. So you'll notice this method actually might even be a little bit quicker, maybe a little bit easier than the substitution method. However, before I say that, we should really say, well, we're not quite done with the problem because we only have half of our answer. Remember, we're trying to find the intersection point of the two lines. So x equals 5 is the x value for the intersection point. But now we're going to need to substitute that in So we're going to substitute that value of 5, into our original equation and solve. So we can go back up to our original equation. We can say, okay, we've got two equations back up here at the top. Which one of those looks a little bit easier to work with? Well, I'm thinking that first equation looks a little bit easier. The x plus 2y, first off, we have all positive values. Secondly, we don't have a lot of coefficients, numbers in front of variables. So what we're going to do is we're going to take that 5 and we're simply going to substitute it in for x in that equation. So that means we now have 5 plus 2y equals 9. And remember, we're trying to find the y value over here, so we're solving for y. Hopefully you're looking at this and saying, okay, well, I'm going to get y by itself, so what we're going to do is undo the positive 5 by subtracting it from both sides. And that leaves us with 2y equals 4. And then we can undo the multiplication there, 2 times y, by dividing both sides by 2. And we end up with y is equal to 2. So now we have both parts of our solution. 5 and 2 means that the point at which these two lines cross is 5, 2. I think that actually is a little bit faster method than the substitution method, and I think a lot of students sometimes think that's the case too. So this is actually kind of a nice method to use. Still algebraic, we're not using our graphs or tables, but we are using our solving equation skills. Now notice that time what we did was we added the equations together. And the reason why we added equation together is because a positive and a negative cancel out when we add them. 4 plus negative 4 is 0. Looking back up here, we actually had a positive 2 and a negative 2 with the y's. 2 plus negative 2 is 0, so that's what did the elimination. Sometimes the elimination is going to happen with the y's, and sometimes the elimination will happen with the x's. You kind of have to look at the equation and see, okay, if I add these equations together, which of the variables will be eliminated? So in this other example down here, you notice that if we add these equations together, it's actually going to be the x's that get eliminated. So I want you to put a plus sign all the way through here because we have to add each part of the equations, kind of like we're combining like terms together. And once again, let's take a look. 4 plus negative 4 is 0. That's the elimination step down here. So that actually gets rid of the x's. Let's look at the y's. Negative 3 plus negative 2y would be a negative 5y. We add two negatives, it's kind of like we're adding two positives, but on the negative side. Negative 11 plus 26 is going to be positive 15. So once again, we get to our solution for the y pretty quickly because the equation simplifies really fast. So if we solve this now for y by undoing the negative 5, we're going to divide both sides by negative 5 to undo that multiplication. And so that leaves us with y is equal to negative 3. Okay? Once again, that is half of our solution, and we're just going to write that. In this case, it's the y value of our solution, so we're going to write that down here in the corner. We still have to figure out the x. So just like we did above, we're going to have to look back at the two equations and say, okay, I'm going to have to substitute the y back in. Is one of those equations easier? In this case, I'm not so sure one is necessarily a lot easier than another. So, I don't know. Why don't we do the second equation this time because up above we did the first equation. Let's take that negative 4x minus 2y equals 26, and let's just write that over here. So what we're saying now is that we're going to figure out what the x value is. So we're going to substitute that in, and since it's y equals negative 3, we're going to substitute it in for y. So negative 4x minus 2 times negative 3 equals 26. So we replaced that y with a negative 3. Now we just have to be careful with our order of operations here. Let's simplify this a little bit first. So negative 2 times negative 3 would be a positive 6. Okay. So now, hopefully you're looking at it and saying, all right, I think I can go ahead and solve this. Working my way back to the x, let's undo the adding of 6 by subtracting 6 from both sides, inverse of adding. So we will then be left with negative 4x equals 20. And then our last step will be to undo the multiplication by dividing both sides by negative 4. So that means that we have x equals, I can't quite fit it down there, so I'm just going to write it over here. X equals negative 5. 20 divided by negative 4 is negative 5. So negative 5 is our x value, and therefore the intersection of these two lines is at negative 5, negative 3.